Okay, so we just want to start the networking basics. Okay, so basics mean let me ask you one question. Okay, so it's general question. Okay, that whenever you go for the interview in firewall or net in security domain and even in networking, people generally ask this. Suppose you want to access www.google.com. Okay, like you got a new laptop and like what will be the process or the things that will happen in background. Okay, so like either Abom or Prasad, can you just give me like what do you think about it? Because I just want to know so that I can you know proceed according to that.
If I got the question, you say if I want to access any website?
Yes. Suppose you type www.google.com in your browser. So what are the process that happens in background?
Okay, when you tap the www, it depends where you are. If you are at home, you're going to hit the gateway that the service provider gave you. And when you get out, you're going to hit the www server to find which URLs have that server. And then you connect it.
Okay. Can you go so deep, like in terms of TCP/IP layers?
Oh yeah, when you I mean, the first thing you have to do when you type the www, you have to make sure that your computer is on. You have the power in the computer, and then it depends what kind of media you're using. It can be a wireless, or it can be the wire, like internet. That is a layer one. After the layer one, it send it connect to the gateway. What gateway is that? The gateway can be the service provider because I'm working at home. Yeah, and then you have that service, that MAC address, and then the gateway pick up the IP address and sends the request out to the server, the www, to find which server is that, and then the connection is made.
Yeah. Prasad, do you want to add something out there?
Yeah, what which Arun said is right, but the thing is, through you're asking the process through TCP/IP layer, right? In the TCP/IP layer, we are having majorly five processes will be there. In the first one, the application layer, which we are entering the www.com, it will first check for the go for the transport layer, then they check for the port number. We'll add the destination port number. And from there to it will go for the network layer, and we'll add the IP address. From there to MAC, and then to physical layer, then starts to gateway. Process in the end. Same process will go at the destination also. In between this, when we are entering www or something, anything, it will first reach the domain as a .com, .co, .in, anything to check the IP address, which is the destination IP we are there to move.
Yeah.
From there, it will pick that IP address, and then we'll start sending the our data to the destination IP.
Yeah, great. So, like, I understand that you both have understanding about the networking. Okay, so it's good. Like, I would not put my efforts on basics. So, thank you, guys. Okay, so let me share my screen. Okay, so I'll just repeat the same things. Okay, so might be you guys have already explained it, but few of the things it will be a brush up for you. Okay, I hope my screen is visible.
Yes, visible.
Okay, so like suppose like let's create topology, and here we have. I'll take firewall as an example for the gateway. Okay, so it's a Palo Alto or internet. We are here, and here we have a server, google.com. Okay, and you have an IP address 10.1.1.10. That is your default gateway. Although, like you can have a switch in between. So I just added a switch. and the default gateway IP is 10.1.1, and here you have an IP address 1.1.1.1. Okay, let's keep it simple. And then the Google server, let's take it 8.8.8.8. Okay, although like it would be different like when it comes to the real scenario, but to understand this, okay, just don't, I'm not using the complex IP notations here. Okay, so first thing, you will type www.google.com. Okay, so what will happen? So like the same example, if we will take on our phone, okay, suppose one of your friend phone number, okay, so it becomes very difficult to remember the complete 10 digits or 12 digits, whatever we are using the country wise. So what we do, we save it with a name. Okay, so suppose you are saving my name Rishi and this is my contact number. So what you did, you just you are using a human readable, or like we can easily remember the name. Okay, so the same thing, it applies to the networking, because the IP addresses, we cannot remember all the IP addresses, like facebook.com. Oh, this is the IP address of Facebook, and this is Google, this is Wikipedia. Okay, so what they did, they are using a simple name. Okay, so suppose google.com, it's very easy to remember for us, okay, or every human being. So we are using google.com, but in background, the traffic is going to the Google server. Okay, and on the internet, like on the network, the traffic flows in terms of source and destination IPs. Okay, at layer 3, at layer 2, we have the MAC addresses, and like layer 4, we have the port addresses. But normally we need the IP address. Okay, so what thing that we use to resolve that IP, that is DNS server. Okay, we use DNS server to resolve the FQDN to IP address. Okay, so when you will type it, so first thing what will happen, it will check your browser cache. Okay, the second thing, it will check your host file. So do you remember, have you ever heard of host file on your laptop?
Yes.
Yeah, so host file, what it was, we can say it was a DNS server for local system. Okay, so when the PCs they started, okay, when we didn't have the DNS servers, so we used to get the list of, because it was very limited to specific users. Okay, we had very limited sites to resolve the IPs. So we used to get those list of FQDNs with the IP address, and we used to put it into the host file. Okay, so our local PC used to work as a DNS resolver. Okay, so but right now we are not using it, but it still checks. Okay, if you have any host entry for any of the FQDN, it will first check the browser cache, then check your host file. Okay, and if it won't find anything, then it will forward it to the DNS server. Okay, then the third one, it will go to the DNS server. Okay, so DNS server, suppose in your company you are using your own DNS server. Okay, so what will happen, your request will go to your DNS server. So what will happen, like DNS server will check its local entries. Okay, same, it's cache, and if it has the details of IP address of google.com, if it has, then it will send the response back. But if it won't have, what it will do, it will forward it further to the root directory. Okay, so like I won't go into the DNS. So like we have the root directory, then we have the TLD. Okay, top level directory in the DNS. Then further, like suppose it will go to com. So because we are using google.com. Okay, then com can have multiple servers, okay, region wise, and there will be so many servers. So it will give you a list of those servers. Then you will go there. Okay, and in between, if any of these servers have the cache, and even if the com like TLD where you are going, and if this server has the cache of google.com, it will respond you back. Okay, I believe you guys know like the basic DNS things. Okay, so the one thing that you need to understand, we have two types of query. One is iterative and one is recursive. So what is the difference between recursive and iterative? Okay, recursive means like I sent you a request. Suppose let's just take an example. You gave some work to anyone. Okay, I give you. Suppose I'm giving you. Okay, Prashad, you need to get these details. Okay, so I want the response from you. Either you are able to get it or no. Okay, I don't want that, Prasad. You will say I'm asking you to do something, but you will say, hey Rishi, can you go and check with Abom, or can you check with XYZ person? No, it will not happen. If I'm giving you something, you have to either say no or yes. Okay, I do not need any reference. So in the recursive, normally our DNS servers, what they do, they send a recursive query to the internet. Okay, so what they will do, the request will go and you will get a response. Okay. Hello.
Hello. Yeah.
Yeah. Okay.
Yes.
So recursive means either you will get the response or you won't get the response. Okay. But in iterative, what will happen? I'm asking, or like the DNS or the PC asked to the DNS server, hey, I want the DNS, like PC requested to DNS server, and what DNS server is doing, you are using iterative query here. Okay, iterative query means your DNS server, if it does not have the details, what it will give you? It will give you the list of servers. Hey, I don't have the resolution for google.com. You go ahead and check with these servers. Okay, server 1, 2, 3, and 4. Okay, it will give you the reference IP addresses of. Then the request will come to the PC, and PC will, then it will send the request first to the first server. Hey, do you know what is the IP address of google.com? If it will say yes, you will get the response. If it won't say, if it won't have the details, what you will do, then you will send the request to the second server. Then second server has the details. Okay, you will get the google.com IP address. If it won't have, then you will go to the third server. So you got it. What is the difference between iterative and recursive? Recursive means I sent a request to my DNS server and now I need a resolution to it. Okay, I won't need any response. Okay, either you say you don't have the details, okay, or you get me the IP address of google.com. Got it?
Yeah.
Yes, clear.
Okay. Yeah, let's move further. One moment. Just clear these things. Okay, now you got the IP address. Okay, 8.8.8.8. Okay, and DNS works at application layer. Okay, then although when the request goes for the DNS server, it just goes in a simple form. Okay, because the source IP we already have it, 10.1.1.10, and destination. Suppose your DNS server IP was 10.1.1.20. Okay, so the destination would be 10.1.1.20, and the source port would be Prasad.
Random port.
Yes. So source port would be random. Suppose it took 2000, and destination port for DNS
53.
Yes, 53. Okay.
UDP.
Yeah, UDP, and it uses TCP as well. Okay, but when UDP, it's a question like DNS uses UDP or TCP. It uses both. But if your query size is less than 512 bytes, then it will use UDP. And if it exceeds 512 bytes, then it uses TCP. Okay. So normally when the request goes from our PC, it is most of the time, 99%, it is UDP, okay, because our query size is very small. But when the traffic, the zone transfer in DNS that happens, like from one DNS server to another DNS server, and the query size is more than 512 bytes, then it uses TCP. Got it?
Got it.
Okay. Now, what will happen? Like we got, okay, so we got the port numbers, okay? What is the address is like at which layer we use port numbers? Transport layer. Okay.
Yes.
And where we use IP address?
Network layer.
Network layer. Okay. Network layer. And then at layer 2, what we have, like Ethernet or like
MAC.
people call it, yeah, MAC. So whenever
data
send, yeah, data link layer MAC to MAC, then it will use the MAC address AA. Okay, so this is how it adds. Okay, a request, even like it adds the IP address, because it follows like a hierarchy. Suppose, why we need a standard for this. Suppose Abom, Abom, you are from US or from where?
I'm US.
Okay, so Abom is in US. Okay, and Prasad, you are in India, or like you are also?
I'm in India.
Okay, so Abom like is in US, and Prasad is in like India. So like if I want to reach or visit to Prasad, I can go by my car. Okay, so I'll take my car and I will visit to Abom, and I can only afford car and I can only drive it. Like suppose we do not have any aviation like aeroplane or ships. So how can I visit to Abom? There won't be any way to visit you. Got it, Abom? So
yeah.
So that's why like we need a standard. Okay, so if I want to go from one place to another place, we should have a standard medium to communicate. Okay,
yes.
Because if I'm speaking Hindi or English language, might be Abom you are speaking any other language, okay, and you don't understand English, so we will not be able to communicate. Okay, that was the reason like they got these TCP/IP model and the OSI layers. Okay, so we will, if I'm transferring any packets to you, you are following the same standards, same type of medium for encryption, decryption, and the addressing schemes. So whatever I'm sending, you will be able to receive it and you will be able to understand it, or your system will be able to process it. Okay, that was the main reason. So that's why, like, if our communication medium is similar or it follows a standard, then we like that. That's why they got these models. Okay, like it's very easy to make you guys understand because you are already aware. Sometimes like we get some people like who do not have networking background, so they don't understand. Okay, so like I'm also explaining how the traffic flows over the internet. Okay, so one moment, let me just give the the IP address is 1.1.1 here. Okay, and here it is 10.1.1. Okay, so here our source IP is 10.1.1.10. Okay, and destination is, we got the resolution 8.8.8.8. Okay, so suppose we are accessing okay, so the source port would be at layer 4, the transport layer. What it will be, suppose 2000 we are using. Okay, it will select randomly. And the destination port, because we type https ://www.google.com. So what will be the destination port? Okay, so do you know what is the difference between HTTP and HTTPS?
UDP is friendly. TCP is like handshake and a window and all that.
Yeah, I understand that. I'll explain you TCP handshake as well. Okay, so just don't worry about it. So this is just to give you an overview. Okay, how traffic flows over the internet. Then I'll explain you like how TCP handshake works. Okay, I'll also do it. So the port for HTTPS we use 443. Okay, and for HTTP, what is the default port or non port is port 80. Okay. So if you are using HTTPS, Facebook.com, Google.com, YouTube.com, Wikipedia.com, and if you are using HTTPS, that means your destination port will be 443. Okay. So let me tell you why we have these ports. Okay. So suppose this is like you are in your like this is your house. Okay. And even if you would have owned in like in universities or in college or in your office, so what we have rooms over there. Okay. Or the floors, like people use it, suppose meeting room 1, meeting room 2, meeting room 3, meeting room 4. Okay. And suppose your CEO, he sits here, your HR department sits in room number 2. Okay. And the person here, he sits in like IT team. Okay. Then you have your account team. Okay. And the same way, if you want to send a letter, okay, you are at your home and you want to send a letter to CEO, okay, to this room, and you don't know like who he is, okay, and even to HR department. Suppose you want to send, and there are 20 people, okay, and you want to send something to him. So what you will do, you will write a letter, okay, to, and the address, okay, room number 2, okay, that will be the city, okay, and the state, and your country. Okay, they come like if you are within same country and sending, then you do not need it. But this is how we add our addressing scheme. Okay, so because the common address of this building is same. Okay, suppose building number 10, and like let's use Texas. Okay, it is in Texas, USA. Okay, so the complete building, okay, its address is 10 Texas, USA. Okay, so they can deliver the your letter up to this building, but suppose this is a 10 or 20 floors of building, then how your address, okay, your letter will reach to the correct person. Okay, so for that, what you need to add one more thing. Okay, suppose it is at floor number 5. Okay, 5th floor, but at 5th floor you have suppose 500 plus people are working, and there are so many rooms in that. So what you need to do, you need to add one more address. What it is? Okay, it is in meeting room 2. Okay, then the person, whenever he will deliver, like he will deliver to specific address, okay, to specific meeting room. And there, suppose in this HR department there are 30 people, okay, and you do not have name, like to whom you want to send it, then you need to mention the name. Suppose like it is Ebon. Okay, so this is how we send our addresses, like any letters. But when it comes to networking, because this is your server, okay, and on servers you have ports up to 65,535, okay, from 0 to 65,535. That means these are number of rooms on that server or ports where you can send the traffic. Okay, that's why we have our known ports. So like suppose for DNS you have 53, okay, port number. For HTTP you have port number 8, for SSL 443, okay, for SSH 422, for Telnet 423, okay, because one server can host multiple applications. Okay, so that's why we use the port numbers, because on this server, suppose you want to access this server, and how you can access it, suppose you want to SSH it or you want to Telnet it. So your IP address will be same 8.8.8.8, but your port number will be different because you want to take the console access of the server. So from CLI, then you will send the request on port 22. Okay, so your request will come on port 22 and you will get the console access. But suppose your SSH is blocked. So what you will do, you will try Telnet. So Telnet will go on port number 23. Okay, then request will go. If it is allowed, then you will get the access. So the same way you are hosting an application, google.com or that. So it will be hosted on port number 443. Okay, you allow port 443 if someone access google.com, but you can also use different port. You can use a known port 4431. It depends on you. Okay, you can use custom ports as well to access for HTTPS or even for DNS as well. Suppose DNS default port is 53. So what you want, you don't want to use 53 as an standard port on this DNS server, on your internal DNS server. So what you will do, you can use 5353. Okay, but for that, whenever your system or PC will send the request, DNS request, you have to modify in your application that the request will not go on port 53, it should go on port 5353. Okay, you can modify it. It's a room. Suppose you have in your house you have 10 rooms. So right now you are living in room number 1. Okay, so like you are living there since 10 years. Okay, it's your room, so everybody knows. Okay, like for Prasad, room number is 1. But after that, you want to shift. Suppose you are planning to shift at first floor in your house. Okay, room number 5. So what you need to do, you need to tell to the people, okay, hey, I'm shifting to the room number 5. Do you want to come or visit me? Then come to the first floor and visit to room number 5. So you will meet the same person. Okay, Prasad was living in room number 1, but now he moved to the room number 5. That means his address will be different, but you will meet the same person. So the same thing, whenever you are accessing any application, as per the INA or the internet standards, they define the known ports, okay, for the applications. Hey, these are the standard ports, okay. Like if you are hosting something or the internet, these are the standard ones that you should use. But if you want to use something different, then you need to tell your requester, okay, who is accessing your application, that you should not come to the default port, you should come to this port. Okay, understood?
Yes.
Yep.
Okay. Yeah, so that is the port. Okay, so we have the known ports. Okay, so for HTTPS, we have this port, and if you will go to the Google, okay, you should know, okay, the basic like TCP known ports. And Google is your best friend. Okay, whatever you want to learn, if you don't understand what it is, just go and type on the Google. Okay, it will give you, and make a habit of it, because I used to be in different companies. Okay, but when I get into the tag, suppose if you want to learn swimming, okay, so there are 2 ways. One, you get a trainer, okay, and who will help you, who will do the spoon feeding to you. Okay, he will hold you and he will tell you, hey, just move your hands like this, then your leg like this. Okay, and after that he will slowly or gradually he will train you. Okay, then you will take a long time to learn things. But there are trainers, what they will do, hey, come on, what they will do, they will just throw you in the water. Okay, and they will just wait. You will learn to move your hands and legs automatically. Okay,
that's true.
Okay, that is the thing. That is the difference between when you work in tag and when you work in any enterprise network. Because in tag they will throw you in the water. Okay, they will throw you on the escalated case. Okay, hey, you just go ahead and learn. Okay, and if you get stuck, then come to me. Okay, so suppose they put you on a case and you don't know about it. So they will say, okay, just go ahead and do the research. You will go to the Google and their internal documents, you will read. Okay, then you will, hey, still I'm unable to get the answer. Then they will ask, okay, what you have done so far. They won't give you the answer. Okay, tell me what you have done so far. Okay, I learned from there, then I understood this, then I learned this, then I understood this. Okay, but at that point I'm unable to understand, what should I do? Then they will tell you the answer, because they know this guy, he put the efforts. Okay, and whenever we learn something, okay, whenever we just go to learn one thing and we do the research by ourselves, then we learn a lot of things, okay, unintentionally. Because when you are searching on Google, there will be more things that will come across during your research. Okay, But if you will directly go, hey, I don't know what it is. This is the customer requirement. Can you tell me how I can resolve this issue? They will not tell. They will say, okay, okay, okay. They won't even respond you. So this is the difference. Okay. So just make a habit. Okay. Whatever you don't know, just go and type on the Google. Okay. You will get the answer. So here, these are the known ports. Okay. Up to 0 to 1, 0 to 3. Okay. These are the known ports. So if you will see here, see for DNS port 53. Okay. Although you do not need to, remember, recall each and everything. Okay. Only the basics. What is the DNS port number? What is the HTTP port number? Okay. What is the HTTPS 443? Okay. And like it's the internet world. So even if someone, even you are in your office and you need, hey, what is the port number of this? Just go and Google it. You will get the answer. Okay. You don't need to worry. But the basic things, okay, that you should know, like, okay, what is the port number of SSL? Okay. Got it?
Yep.
Yeah. Whatever doubt that you have, Google is your best friend. Okay. So, okay, let's come here. So we are using the default port here, okay, of HTTPS, okay, that is 443. Okay, 443. Then it will come to the layer 2. Okay, the MAC address. Suppose the MAC address of this PC is AA, and this is BB, and this is CC, and this is DD. Okay. This is the MAC address. So what will happen? It will just create the header. Okay. The source port will be AA, destination port BB. How it decides that? Okay. Let me tell you. Let me ask you one thing. Suppose, whenever we configure IP address on our PC, okay, what we give? IP address 10.1.1.1. and the default 10.10 and the default gateway 10.1.1.10. Okay, default gateway and the DNS server. Okay, DNS server, we know the answer. Okay, why we use. But how the PC will decide I need to send this traffic to default gateway or to local system? Because suppose google.com, it could be here. Okay. Your google.com can be here and the IP address resolution is 10.1.1.100. Okay. Then how it will decide that I need to send it directly to this google.com or to my gateway? It performs the AND operations. So how the AND operation works? It takes the source IP 10.1.1.10. Okay. And here we have /24. Okay. The subnet will be /24, and it will take the destination IP after the resolution. Suppose your destination IP is 10. For google.com 10.1.1.100. Okay. So what it will do, it will perform an AND operation. That means it will check, okay, /24 means the first 3 octet will be fixed. Okay. So it will fix these octets. Okay. And it will check, are these same in destination IP as well. Okay. So 10 is same. After the second octet, 1 is same. The third octet is also same. It means the destination, it is in my own LAN. Okay. It is not over the internet or even in different LAN segment. Okay. Or subnets. Abom and Prasad, you understood this?
Got it.
Okay. So how our PC decides that the destination is within my LAN or outside my LAN? It performs the AND operation with the destination IP. Then suppose the destination IP is not this, it is 8.8.8.8. Okay. So it will just fix 3 octets of the source IP, and then it will check the first octet. Okay, 8. Oh, this is not the same. That means my destination is outside my LAN. Then I need to send the traffic to my default gateway. Okay. This is how the PC or even any networking device, they decide the traffic should go to the local LAN or to the default gateway. Okay, because in the background the ARP resolution happens. Okay.
Yes.
So the ARP, should I resolve the ARP for my default gateway or directly to the destination IP? So this is how it decides. If the first 3 octets or even the octets of the source and destination matches, that means the destination is in my local LAN, and when I will send the ARP request, so the ARP request source IP will be 10.1.1.10 and target IP will be 10.1.1.100. Okay, but when the destination is outside your LAN, then your ARP request will go for your default gateway 10.1.1.1. The target IP, the okay, so your target IP will be in the ARP request, your target IP will be the default gateway IP. Understood?
Yeah.
Okay, yeah, great. So let's move further. Hey, there are so many logics in background. Okay, so I'm just trying my best to explain it to you in easy way. Okay. 1 minute. Remove these things. Okay. Okay, so now we got the ARP request will go for our default gateway, and the Palo Alto, it will resolve the IP, MAC address of its own BD, and then our traffic will come here. What it will do, it will put this 10.1.1.10 port 2000 and the data part, and 8.8.8.8.443 into this header. Then the packet will reach to our Palo Alto Firewall. So whenever, the significance of Ethernet header or the addressing scheme at data link layer, it is within the LAN, okay, within the same broadcast domain. So whenever it reaches to a next layer 2 device, what it does, the first thing, it removes the header, okay, it deletes that header, and it will take the IP address of 10.1.1.10 and destination is 8.8.8.8.443. Okay, and here the port 3000. So the request come here. After that, when the firewall will forward, or even any networking device, routing device, then whenever they will forward this packet, they will add new MAC addresses, okay, at layer 2, because here you are forwarding this traffic from this port, okay, from this port it will go over the internet. So what is the MAC address of this? CC. Okay, so the next Ethernet header that it will create, the source MAC will be CC, and destination MAC, suppose there is in router, okay, and its MAC address is XX. So your target MAC will be accessed, because the ARP resolution between this and this, it will be directly. Okay, understood?
Yep.
Yeah, great. So now you understood the layer 2. Okay, so I will not include layer 2 here. Okay, I will only include the layer 3 and further communication. Okay, so what will happen? Okay, so now we got this IP address here. Okay, but here, if you will see, our source IP is 10.1.1.10. Okay, and here we are forwarding it over the internet. So our significance of the private IPs, the RFC 1917 traffic, you cannot take them over the internet. Okay, so in the RFC 1719, the IP range is 10.0.0.0/8. Okay, but then 172.16.0.0, like it just goes from 16 to 32. Okay, to in the class B. Okay, and in class C we have 192.168.0.0/16. Okay, like from 0 to 0 you can use it. Understood? These are the RFC 19 1917 IP addresses. Okay. So for this, what we need to do, we need to perform the NAT. Okay. So what is NAT? Okay, NAT is very simple. People, sometimes they complicate the netting, but NAT is very simple. Whenever you change the source IP of the packet, we call it source NAT. Okay. And whenever we change the destination IP of a packet, we call it destination NAT. Okay. So normally, whenever in any organization you are trying to access internet, okay, google.com, Facebook, normal surfing that you do, we use the source NAT because inside your office you are using the private IP range. Okay. But when you are forwarding the traffic over the internet, you need a public IP address. So this is the packet, okay, layer 3 packet that we received on our firewall. Source IP is 10.1.1.10 and destination is 8.8.8. So because what will happen, even suppose you are not doing NAT, so what will happen, although like the ISP these days, they perform the source checking these days. Okay. So if the packet contains the source or destination IP from the private range, it drops it itself. Okay. It won't even forward it to the destination. But suppose you are not doing NAT, or even this ISP is not checking the source IP, so what will happen, your traffic will reach here. Okay. But when the 8.8.8 will reply, so what will happen? This is your source and destination will be your 10.1.1.10. And this is the private IP address. Because if you want to send a letter to anyone, you need to put his address. You cannot directly say, hey, room number 1 in Texas. Your letter will never reach to the destination. You have to tell, okay, in Texas, will be the city, this will be the area, this will be the street, this will be the house number and the room number. Okay, then your letter will reach, because 10.1.1, this is the private range. Okay, all the organization, in your LAN, they use this IP. So your traffic or your packet will never come back. You can send your traffic because the destination IP is public IP and this is the IP address of this server. So your ISP can route this traffic to the destination, but your return traffic will never come. Okay. Because whenever we access google.com, so we request, hey, give me the homepage of google.com. So the homepage that you see where, it is written Google. Okay. So that is being forwarded by the server. So you will never receive that response. That's why to forward the traffic over the internet, we need the netting. Okay. So what we will do here, we need source net, because our private IP in these two addresses is source IP. Okay, so we only need to change the source IP. But if you want to change the destination, you can also do it. Okay, it comes to the scenario, but just don't confuse yourself. So we are changing this IP. We are performing NAT. Okay, so the NAT, how it will be? Suppose this is our public IP. So 1.1.1.1. Normally, it uses the same port number if it is not used by anyone. Okay, so suppose you have another PC and they are using port number 2000. So what it will do, it will select any other port number. But normally, if that port is not being used on this IP, what it will do, it will use the same port. And your destination will be 8.8.8.8 and port number 443. So now your packet is ready to forward. Then it will go to the internet, and when the packet will reach here, okay, so when the packet will reach, this will be the IP address, source 1.1.1 port 2000, okay, and destination 8.8.8.8.443. Okay, this is how your packet will reach. Okay, your server will receive it and then it will forward, it will respond you back. So after response, what will happen? Because so far this was your source and this was your destination, but even whenever you respond to someone, what you do, you put his email address. Suppose you Rishi is sending email address to Abong, so I am in the 2, I put your email address. But when you will respond me back, so what you will do, you will reply. So in the 2, the email address will be mine. Okay, so the same thing will happen. The addresses will be swapped. Okay, your source will become destination and destination will become source. So this will be your source and this will be your destination when the response will be back. So the port number will still be same. Okay, why? Because when we do NAT on our any router or firewall or any layer 3 device, so it creates a NAT translation table. That means I changed 10.1.1.10 to 2000, okay, to 1.1.1.1 to 2000 port. Okay, it just keeps that entry. So whenever the return traffic will come and the destination is 10.1.1.2000, then it will automatically change this IP to this private IP. Okay, so suppose the server it added the data part, okay, and it responded back. So your source will be 8.8.8 and destination will be 1.1.1. So your traffic will reach to the firewall. Here it will, when you will receive the traffic, this will be your packet. So what it will do, it will check, okay, the destination is 1.1.1 2000. Okay, do I have any NAT translation entry in my NAT table? Yeah, it will say yes, you have it. You need to change it back to this. So what it will do, when the packet will come here, it will change the okay, after this, our packet again will become 8.8.8.8 will be the source, port 443, and destination will be again after translation 1.1.1 2000. And here it knows, it will check the routing for this destination where I need to send. Okay, you need to send into this LAN part, and your packet will receive on this PC. Okay. Understood? Any question, any doubt on this traffic flow? This is how the traffic flows over the internet.
I have a question.
Yes, clear.
Okay. So because, even when, I started my career, I even didn't know there is a return traffic as well. Okay. We only knew we are forwarding packet. Okay. The traffic is going. Okay. But the return traffic should also be allowed. So in the firewall, whenever you are allowing any rule, so I'm talking about the tradition. Okay, let's take a router. In the router, we create ACLs. Okay, access control list. So in the ACLs are like stateless policies. That means if you are allowing anything from suppose 10.1.1.0/24 to 8.8.8.8, that means you have to allow the return traffic as well. Okay, you need to create two ACLs from 8.8.8.8 to 10.1.1.0/24. Correct?
Okay. Yes, we need to allow on the inbound and outbound both.
Yes, we create inbound and outbound both. Okay, but when it comes to stateful firewalls, like these days we have all the firewalls like stateful. You only need to allow one side. Okay, the another side gets automatically be allowed. I'll tell you how it will work. So any doubt in this traffic flow?
I don't have any doubt, but I have a question.
Yeah.
The NAT table is have like a time to leave, or when the traffic come back, it just destroys that table?
Yeah, once you receive the response back, it will destroy it. Okay, the session terminates. So what happens, like the sessions are created here. Okay, so suppose you sent a ping. Okay, so in the ping, what we have, echo request and echo reply. Okay, so your traffic will go and then you will receive the response. Once you receive the response, like your NAT entry will automatically be deleted because the response is only once. Okay, packet sent, packet received, the communication is done. Okay, but in traditional devices, they used to have some time. Okay, that I'll keep the entry for that particular time. Okay, even on your router, you can see the NAT translation table. You can clear the NAT entries or NAT translation table as well. Okay. So, but these days you do not need to worry about it. Okay, it happens automatically because these are the session-based firewalls or devices that we have these days. Okay, and you will rarely find any router like that is performing NAT. Okay, it's most of the time the security appliances, firewalls, they perform the NAT. Okay.
Okay.
Okay, so yeah, that's it with the traffic flow. Okay, how like traffic flows over the internet and even basics on the DNS. So I would, tomorrow, like I'll explain you. But before that, I want you guys to, go on YouTube, okay, and go on Google. Just type TCP handshake. Okay, this is the one thing, and the another thing you need to check. So the another thing is, okay, first thing is TCP header. You would have never, like you need to know what are the like options or fields that we have in TCP header. Source port, destination port, sequence number, acknowledgement number. Okay, and here it does not have it more details. Okay, let's open this one. Okay, the flags. Okay, urgent flag, URG, ACK, acknowledgement, push, reset, SYN, and PIN. Although, like whenever I'll explain you, like you will understand it. Window, checksum, and urgent pointer. Okay, so these are the fields in TCP header. Okay, then go to Google and search header. Could you please make a note of it? UDP header, just go and click on image. Oh, and UDP header is the most simplest header in this world. Okay, source port, destination port, length, and checksum. Okay, that's it. And then it adds the data. Then the IP header. Okay, in the IP header, let's take okay, which one? Okay, yeah, these things. Okay, you just have a look over it, okay, and try to understand. Okay, so how you can understand the headers. Okay, just open it. Source port, because you guys are already aware. Source port, okay, this is the addressing scheme of our transport layer. That's why it uses source port and destination port. It means all the protocols that we will be using at transport layer, okay, or the transport layer protocols, they will be using this addressing scheme as in source port or destination port. Okay, then if we are, so suppose UDP, it uses source port, destination port. If you will compare their header, okay, the addressing scheme is same. Okay, this is the common thing. And if you will take SCTP, like it will also be using the source port and destination port. Then sequence number, although like it is not that important, but whenever we will be having this discussion on the handshake or how TCP traffic flows, then you should know, okay, what is sequence number. So sequence number is nothing. It's just the number, okay, how many traffics or the packets that we have forwarded, okay, and what will be the next packet, or just to, because TCP gives us the reliability, okay, that whatever you are sending, I guarantee you forward the same data to the destination. If something drops, I will resend. If something again drops, I will again retransmit it. Okay, so it gives you guarantee. Okay, so that's why we use these sequence number and acknowledgement number. Okay, then we have these flags. Okay, these are very important. Okay, when you want to learn the TCP, okay, and even if you want to move in security domain and get into troubleshooting, so you should know about these. Okay, although like most of the time you will see SYN, PIN, acknowledgement. Okay, most of these, okay, urgent, RST, and the push you will see rarely, but I'll tell you what is the significance and what is the meaning. Okay, but I want you just have a look over it when we connect tomorrow, so that you will be familiar with these terms. Okay, okay, like this is talking about URG. Okay, I know, like this is the flag of TCP. Okay, so just go ahead, and this is how you can learn. Okay, window, then go, okay, what is TCP window field? Okay, just open this, second, then third, just open 3 to 4 links, okay, and then go wherever you find easy, okay, their explanation is good and you find it easy, then read from there, okay. It's not mandatory that you always just go for the first link and learn it, okay. Abong, Prasad?
Yep.
Okay. So just go ahead and research it, because whenever we will be discussing it tomorrow, at least you guys will be having an idea, okay? And might be you have already read it, okay? And even it's a normal human tendency with the human beings that if we do not use anything for a long period, then we start forgetting it, okay? But whenever we just brush up it again, okay, oh, this is how it is, then we just recall it, okay. So we can say disadvantage and as well as more advantage. So it means repetition always makes us perfect, okay. So you guys are already aware, but now you are moving into the security domain, so I'm just giving you an idea, okay, that these things are very important,
okay.
Because when you will be doing the troubleshooting or the firewalls, and when you will be creating the security rules, because in security rules, when we create security rules, what we need the source IP, we need the destination IP, we need the source port, we need the destination port. So we should know what is the significance and why we need it, okay. So whenever you will be working on these firewalls, and users will be coming to you, hey, I want to create this rule, okay, just give me these details, I need the port details as well. You cannot allow any ports, because suppose you are accessing google.com, that you only need access to port 443, then why would allow other ports as well, okay. And even suppose you are hosting a server in your local LAN, suppose abom, like www.abom.com, okay, and users are accessing or getting details about you and your organization, so you only want to open one door for them, okay. You cannot, hey, you can come to access our 65,535 ports. Might be by mistake you kept one of the port open, and the attackers, they attacked, they sent the packets, okay, on all the ports at the same time. That means your server or will be exhausted with the resources and it will be down, okay. This is how our normal deep flood attacks they happens, and the port scanning attacks they happens. So they just, it's the same thing. Suppose you have your house, okay, and you have 5 gate doors in your house. So what the thieves, okay, the people like want to intrude in your house. So what they do, they just watch, okay, oh, which door they open, mostly, and they will come to your door. Might be sometimes you just close your door, but you didn't latch it, okay. So they will come and check, oh, they will knock it, oh, this door is open, just keep it open. Whenever they will go out, I will just get inside from this door. So this is what happens in the network domain as well, okay. When it thinks, these, if just try to relate these things, networking things with the real world examples, then it will become very easy for you to understand. Because what is routing? You want to go from one place to another place. So suppose you are going for the first time. So what you will do, you will ask the people, hey, I want to go to this place. Can you tell me which way I should go? Then they will tell, okay, you should take this way, go straight, then take left from there. So the people or the person who's telling you the route, he's the router. Okay, so in the networking domain, what happens? We have the layer 3 devices or routers, like where we configure our routes. If you want to reach to any specific destination, they will tell you, okay, to this way you should go. Okay, and in real world, if you will say, we have the signboards on the roads, okay, on the highways, they are the routers. Hey, if you want to go to this city, then this city, take right, left, it is 300 kilometers from here, okay. So those are routers. So the same thing in the networking field, we are using layer 3 devices, the routers that tells or that directs our traffic towards the destination. Okay, so that's why the same, if I come back to our that example, the door kept open, you didn't latch, then you are outside, okay, you are not watching that door. So they will, whenever they will get chance, they will get into your house, okay, and they will just get everything from there. So the same thing, it happens on the server. If you are keeping the other ports open, those are not necessary. That means you are inviting the attackers, okay, to get into your server from those doors. So always allow the specific ports that is required. Okay, that's how you should have the understanding about these ports and addressing scheme, at least at layer 3 and layer 4. Okay, and the headers.
Okay.
Okay, so just don't worry, I'll try my best. Okay, I always try to relate things with the real world examples. Okay, so that the networking becomes easy, because in initial days I have been struggling this. Okay, but when I understood, okay, just try to relate things with the networking, then with the real world examples, the networking is, it becomes very simple. Okay.
Okay, thank you.
Okay, so like from tomorrow, you just go ahead and try to do research by yourself. Okay, just try to understand. Okay, just go to Google, what is urgent pointer, urgent flag, what is acknowledgement flag, what is push flag. Okay, just try to understand by yourself. Okay, because when you will come prepared, then tomorrow when I'll tell you, okay, this is what it is. Oh, then there will be two conditions. One, you already know it. Okay, the other thing might be you understood something different. Then I tell you, okay, this is what it is. Then it will clear your doubts. Okay.
Yeah.
Simple things: TCP header and UDP header and the IP header. Okay, just try to understand each and every fields in it.
Sure, definitely.
Okay. Okay, so our Zoom link will be same. Okay, that I have shared on the Zoom. So it's a recurring meeting. So you need to join it on the same. Okay, on daily basis.
Okay then.
Yeah.
Okay.
Any doubts, any questions, or like anything that you want to know about, about Palo Alto or anything? Prasad, Ebon?
No.
Oh, great. So
everything is clear as of now.
Sorry?
Everything is clear as of now. We'll join tomorrow for the morning.
Okay. Thank you, Prasad. Thank you, Ebon. Thank you so much for your time and have a nice day.
Okay. Bye-bye.
Bye-bye.